He's also the author of a book called Carl Sagan and Immanuel Velikovsky, which is going to be re-edited and published for the conference in June. He's also one of the people at work on a book called The Continuing Velikovsky Affair. And today, he's going to talk about Venus. Charles Ginenthal.
What? Good afternoon. It's a pleasure to be here. And I'm not so much only going to speak about Venus, I want to speak about science. I appreciate Tom Van Flanderen's remark about whether we're not fooling ourselves. And I find that Tom Van Flanderen is a very decent, an extremely honest man, and he's paid a price, as Victor Klube has, and as others in science have, for going outside the mainstream. He told me an interesting story, and I asked the question, what kind of response do you get from your colleagues when you explain to them that so many bodies in the solar system are all either dark on one side or cratered mostly on one side, and this makes incredibly difficult, makes it an incredibly difficult problem to explain in terms of each one having a unique way in which they became cratered on one side or darkened on one side. And he said to me, one of my colleagues said that if my theory turns out to be correct, I'll go out into the middle of NASA and take off my clothes. And I think on a psychological level, he was saying that the emperor has no clothes, that many of the modern ideas about the solar system or theories about the solar system are really emperors without clothes. Velikovsky wrote in 1950, before the space age began. At the time, there were many, many theories about what we would find at the various planets, what they were like. Copernicus, fortunately, when he wrote his Revolution of the Planets, died, and along came a man named Galileo who used a telescope, and suddenly there was all kinds of new evidence. The evidence was that Venus went through crescent stages, as did the moon, so did Mercury. The moon had mountains on it. It wasn't perfect. The sun had spots on it. It wasn't perfect. Jupiter had 4 little worlds going around it. The Earth was not the center. Apparently, Mercury and Venus were going around the sun, the moon was going around the Earth, and 4 worlds were going around Jupiter. What was the response of the establishment at that time? They turned, either they used vilification, and we all know what happened to Galileo, but they invented ad hoc hypotheses after ad hoc hypotheses in order to support the theory. The moon suddenly not only had mountains on it, but over the mountains were pure glass, so that the moon was now a perfect body, perfectly round, but there was a wall of glass around it. And they took on the Tycho Brahe theory that the Earth was still the center of the universe. The Earth would not move. The moon went around the Earth. The sun went around the Earth. And all the planets went around the sun. They would not allow the Earth to move. They created one ad hoc hypothesis after another in order to save the appearances. the job that Plato had given to his students to make the Earth the center of the universe. I'm suggesting, before I begin talking about Venus, that many of the explanations of the evidence that was brought in after 1950 to explain what was found on the planets and the moon are not really very different. In fact, in some cases, in one case I'll point out, it was simply throwing evidence away again and again and again. So we know what Venus looks like, but what was the scientific world's view of Venus in 1980 and 1983, 84, 85? Velikovsky said it was probably a new world, or if we look in terms of David Talbot's work, it was a world that had undergone immense devastation during the explosion of a planet. What would we expect to find in terms of Velikovsky's thesis? Well, from his analysis of the mythological evidence, he drew the conclusion it was probably a planet that was in the cool-down stage of its development. Therefore, if his understanding of this evidence was correct, then Venus should exhibit all the conditions of a world that was very recently molten over its entire surface. It should be stupendously volcanic and display immense volcanic structures over every region of the planet. In 1983, Lawrence Collin of NASA's Ames Research Center stated in a highly regarded volume, Venus, put out by the University of Arizona with 69 collaborating scientists, that basically they felt that Venus would be a hot, dry, dusty global desert. That was the consensus opinion from everything they had thought about. That is, in 1983 and beyond, the scientific establishment maintained Venus was not very volcanic. It might have had some volcanoes, but essentially it would be a desert. Nowhere was it suggested that the entire planet would be covered by volcanic terrain over the, and be eventually volcanic. What did we find when we got there? A man by the name of Harry Grispoon summed it up rather well, and I'll read from what he wrote. Quote, "Perhaps the most striking feature of the Venusian landscape is the prevalence of volcanism. About 80% of the surface is made up of volcanic terrain, ranging from the curiously familiar to the downright bizarre. 100-mile wide, gently sloping volcanoes, similar in appearance to the shield volcanoes of Hawaii, abound on Venus. Their flanks are covered with numerous overlapping lava flows, the most recent of which appear to have erupted only yesterday. Smaller, flat-topped pancake domes have formed where more viscous lava has been squeezed up through the crust. Huge areas of the planet are covered with flat, voluminous, and almost featureless lava flows. Some of these are continental in size. That is, an area the size of a continent is literally covered with lava flows. Thin, meandering channels are visible, some extending for thousands of miles. The channels of Venus are believed to be volcanic in origin. And there are also many other kinds of terrain. Except for a few zones of concentrated volcanic activity, the various forms of volcanic terrain are widely dispersed across the surface of Venus. Now, according to Eberhard, the number of volcanic domes on Venus run into the tens of thousands. One research investigator with the team analyzing Magellan observations remarked, quote, "Everyone says Mons Olympus on Mars is the biggest volcano in the solar system. It isn't. Venus is. The entire planet is one big volcano." Nigel Henbest displayed a radar images enhanced to show Venusian topography of, quote, mountain ranges and volcanoes that contort the surface of Venus, where a giant plateau, Lakshmi Planum, drops down to the plains, from which Magellan spacecraft showed solidified waterfalls of lava. That is, close quote, that is, there is an enormous plateau, and actually running down from the plateau are what we can see as frozen waterfalls of lava. He goes on to remark, magma can well up to create a planet-wide scattering of at least 100,000 volcanoes of all sizes. The radar images cannot show if the Venusian volcanoes are still erupting, but geologists are convinced that many must be currently active. Detailed radar images show parts of Venus so rough that they resemble very fresh lavas on Earth. They have, close quote, they have one volcano which is 8,500 meters or over 24,000 feet, or 28,000 feet, that's 5 miles high. And he says, quote, Soviet orbiting spacecraft have found spots on Venus so hot that they can be active volcanic vents. Now, this picture of Venus as covered with volcanoes is well known to the scientific community. In fact, in the 1950s and in the 1970s, the atmosphere of Venus seemed to suddenly fill up with dust and sulfur dioxide. This was found by the International Ultraviolet Explorer. It was corroborated by the Pioneer Venus and Venera landers while they were there, that this was what they saw from Earth, this is what was measured in the Venusian atmosphere. Larry Esposito, one of the researchers, said that, quote, the best explanation right now for the decrease, that is the decrease in the dust and other materials, is that from time to time, major volcanic eruptions inject sulfur dioxide gas to high altitude. The haze comes from particles of sulfur dioxide, which is created by the action of sunlight on it. Being heavy, the particles gradually fall out of the upper atmosphere, letting conditions return to normal between eruptions. That's Esposito's calculations, show that the eruptions of the late 1970s was at least as large as the 1983 explosion of Krakatoa. The explosion equal to a 500 megaton H-bomb was the most violent of last century, close quote. So we have now a picture of a planet which is highly volcanic, has thousands and thousands of volcanoes, and is totally different from what was expected. Of course, it's not at all totally different from what Velikovskyans expected. That is, before we got there, I literally had the shakes. I said, if this place isn't volcanic, pack it in. But I didn't. I was extremely, extremely surprised because I wasn't all that sure, nor am I sure to this day, that my views will be supported by evidence, that is scientific evidence. But here suddenly, to my great surprise and relief, since I am an advocate, I'm not ashamed of being an advocate, I want to be an honest advocate, that the planet showed it was tremendously volcanic. But it had to be more than volcanic. Venus had to be pristine. Its topography had to be extraordinarily young to fit the theory that I was interested in Velikovsky's theory. According to Richard A. Kerr, in an article called Venus is Looking Too Pristine, we have the following, quote, "The planetary geologists who are studying the radar images streaming back from Magellan find they have an enigma on their hands. When they read the geological clock that tells them how old the Venusian surface is, they find a planet on the brink of adolescence. But when they look at the surface itself, they see a new-born babe. Magellan scientists have been struck by the newly minted appearance of the craters formed. Only one of the 75 craters identified on the 5% of the planet mapped so far show any typical signs of aging. But by geologists' usual measure, these fresh-looking craters had plenty of time to fall prey to the ravages of geological change," close quote. After Magellan had completed its mapping of Venus, the pristine condition of the topography told the very same story. That is, everything appeared to be brand new. Grisboon states, quote, "But there is something quite strange, almost unnatural, about the Venusian craters. Clearly, all of them appear pristine, as if planted there recently. Indeed, virtually every geological feature of the planet appears brand new," close quote. Now, all this evidence is starkly and strikingly in accord with Velikovsky's theory of Venus as a newborn planet. What has the scientific establishment's response been to this? Well, what they did is they were forced, of course, by the natural weight of the evidence, to say something about this appearance. And so they have created an ad hoc explanation that somehow between 100 million and 500 million years ago, an event of such momentous and powerful behavior occurred, an explosion, an interaction or something, literally turned Venus totally inside out. Now, that's a reasonable supposition. And if the supposition is correct, then it should be supported by other evidence. But I'm afraid when we look at the other evidence, it does not support that viewpoint. And I'm talking specifically about erosion on Venus. We know that the planet has an acid atmosphere. We know from the observations, and I have several quotations here from reputable scientists, that they see the rocks on Venus and they say there's erosion. There's hydrofluoric acid, there's sulfuric acid, sulfur, and these other two acids will form something called fluorosulfuric acid, which will eat rock. In addition to that, if Venus has been traveling around in space for 100 million, 200 million, 300, 400, 500 million years, and it's had some volcanic eruptions throw, explosive volcanic eruptions will throw sometimes 4, 5, 6 cubic miles of what? Of dust and debris onto the surface. Some of this seems to have been found. That is, near certain volcanoes, they seem to see debris. But that's not what most of the planet is like. Most of the planet, according to Grispoon, looks like this. In effect, he says, quote, Venus looks much like an Earth that is arid and devoid of erosion. The absence of erosion, however, goes only partway toward explaining the strangely fresh appearance of the undegraded crater population. The problem is this: a surface less than 1 billion years old is still unusually young by planetary standards. Close quote. Venus is nearly completely bare rock, with a little dust here and there in between the craters. And of course, those few areas where there seems to be some material on the surface, but by and large, it's all rock. Henry S.F. Cooper, the science writer, points out, quote, all the bedrock of Venus is exposed. The entire planet is like a big road cut. What we're looking at is total outcrop, total exposure of everything that happened to it. Now, how do you stop erosion on a planet? Either we stop erosion on a planet or we invent another ad hoc hypothesis to reconsolidate rock back into, or dust back into rock so that it looks like the kinds of rocks that we see given out by volcanoes. There is another way that Venus would be getting dust or a regolith on its surface. Dust is falling from space. Comets are constantly depositing dust in the inner solar system as they near the sun. Venus should be picking up this dust as well. The Earth every year picks up about 40,000 tons of this dust, which is, according to Sky and Telescope, the best estimate they have of how much dust is collected on Earth. We put this all together, and I'll say, let's say the dust and the erosion and all of it builds up at 1/1,000,000th of a meter per year. In 3 million years, we have almost 10 feet of regolith over the entire planet. There's no 10 feet, there's no 9, 8, 7, 6, 5. There is no regolith on this planet. What the scientists are doing is what I saw that they were doing at Mars. Mars has dust storms going on for months at a time. These dust storms blow for 3, 4, 5, up to 6 months. If you recalculate back to when the planet supposedly solidified, had rivers on its system, we have almost 200 million years of dust storms. And yet we find river valleys, pristine sometimes river valleys that David showed us on Mars. Many of them with dendritic systems, that is, with 40, 50, 60, 70 tributaries entering various other rivers and coming down like an enormous fan. Now, nothing like that could last. In the same way on Venus, I find it extraordinary that something that I taught to junior high school students about erosion could be dismissed so easily as I saw it was in the Skeptical Inquirer a few years ago when people said erosion is not an important part of the age of Mars. I think it's a very important part. There is another problem with Venus. And this problem also is a problem for some of us who support Velikovsky. And it's the problem called rheology. That is, rheology is not a theoretical science. It is a science. It's measurable, it's known, it's understood. Rheology is the way in which rocks behave under the force of gravity and heat. That is, the greater the heat, the faster you can get rock to become degraded, to be pulled down by gravity. Some scientists, to explain this to laymen, use the term that Venus's surface is like peanut butter. I like peanut butter. I liked it all my life. And I like this view. Now, how long can the surface of Venus maintain high topography, enormous chasms? And the answer is not very long. According to George McGill, again from the book Venus, he says creep rates of rock are strongly temperature dependent. If the high surface temperature of Venus implies a much hotter crust, then the entire crust of Venus may be much less resistant to creep than the crust of the Earth. Cordell and Solomon and their associates have found that large features such as impact basins will suffer essentially complete relaxation or flattening to the surface of their topographic relief in the time order of 1 billion years. That's even if the Venusian surface is dry. That is, the wetter the surface, the faster rocks will flatten down. Therefore, if Venus is truly an ancient body, 100 million, 200 million, 300 million, 400 million, or even 500 million years old, most of this stuff should have pretty much disappeared. That is, the planet should be mostly flat, and most of the planet is flat. It has a few high areas called continents. A fellow by the name of Phillips and his associates came to the conclusion that the continents of Venus, if they're not supported by upwelling, they would literally flatten out in 10 million years, and yet here they are. McGill said that these places have to rise and fall and rise and fall and rise and fall again and again in order to explain what's going on Venus. It's illogical to assume that this stuff lasted from the very beginning or existed from the very beginning, and it lasted up to the present time. Again, I suggest that this does not make any sense. In terms of Velikovsky's theory, there are problems. How do you hold this stuff up? Well, if two parts of a planet are held up, there could be upwelling because the scientists are using that. I don't like that kind of approach. Perhaps David Talbot is correct that Venus was near another body and had time to develop a fairly thick crust before it received the full impact of a planet going almost nova. That would make, to me at least, more scientific sense. It would be more comfortable for me. I don't like holding up continents by upwelling, even if this is what is being done by other individuals. Now, Velikovsky's viewpoint that Venus is a hot planet is also based on the concept that if it is a newborn planet, its heat is coming from below the surface. When the scientists measured the heat of Venus, we all know, they found it was hot. And Velikovsky was attacked for not saying how hot it would be. All right, that's fair enough. But when they found that the surface of the planet was hot enough to melt lead, the scientists, of course, had to resolve this with a particular concept which they developed called a greenhouse, a runaway greenhouse. And that's the theory that was put forth. Now, if there is a runaway greenhouse, and Velikovsky is wrong, then the heat of the planet will be coming from its atmosphere. And there is a way to measure this. That is, we can measure how much sunlight is captured by Venus, how much heat is coming from Venus. If the atmosphere is heating Venus, then the sunlight coming in will be equal to the amount of heat coming out at all levels. Now, at this point, I have to say that the behavior of the scientists in this regard, and I'm going to use a term that's really very, very ugly, but it was despicable. I'm going to use that term, and very advisedly, because I believe the behavior was despicable. Velikovsky said that the heat would be coming from below, wherever you measure, the what? The gradient, the amount of light in the planet, the amount of heat coming out, they will not be equal. There will be more heat coming from the planet than coming in as sunlight. That means that the planet is not producing the heat from a greenhouse effect, but that the heat is coming from below the surface. The closer we get to that surface, the greater should be that difference. It's like putting your hand next to a white hot bar. The way in which heat comes off, I believe it's to the fourth power, don't quote me on that, I'm not a physicist, but as you come closer, it gets warmer and warmer, and suddenly gets very warm and extraordinarily warm. What we should expect then is that as you get closer to the planet, the greenhouse effect, because I'm not doubting there's a greenhouse effect, it's whether or not the greenhouse effect is producing the heat. There were 3 sets of measurements that were taken by probes to the planet, by Pioneer Venus, Venera, and Venera Landers. At the cloud tops, they took the measurements of how much light is entering, how much heat is leaving. There were 4 measurements, and after looking at them, in that book, Venus Again, the scientists, that's Taylor and his associates, were forced to say the following, and that was very honest of them to say this, quote, "Clearly, the Pioneer measurements of emission and reflection are not consistent with each other if net radiative balance occurs. A source inside Venus, equal in amplitude to 20% of the solar input, that is accounting for the difference between the readings they got, is very unlikely, close quote. That is, the measurements show that the cloud tops of Venus would be emitting 20% more heat than sunlight could deliver to the planet. The scientists said that in order for this additional heat to exist, volcanism would be required. And they go on to admit, quote, fresh-looking volcanoes do appear to exist on Venus, and the composition of the atmosphere is consistent with vigorous output from these. However, a reevaluation was done of the readings. And what they eventually did was to keep only one reading, that by a man named Tomasco. And the others were more or less corrected, there was changing, and they actually said the following. In conclusion, then, the best thermal measurement of Venus with the assumption of global energy balance yield a value, and what was that value, close quote? It was thermal balance. The greenhouse effect is supported. This, I suggest, is not science. But what about the readings from the cloud tops down by the 4 Venera landers? Were they at least going to show thermal balance? According to Richard A. Kerr, quote, when 4 Pioneer Venus probes looked at the temperature, each one found more energy being radiated up from the lower atmosphere than enters its sunlight. To further complicate the situation, the size of the apparent upward flow of energy varies from place to place by a factor of 2, which is a disturbing discovery, close quote. What Velikovskians would suggest is that the runaway greenhouse effect in an atmosphere that is as heavy as a 3,000-foot deep ocean would not have tremendous hot spots in it, in its middle regions. But if areas of Venus are tremendously hotter than others, which would be expected on a volcanic planet, highly volcanic planet, this is exactly what we would find. According to Pioneer Venus publication, quote, the measured infrared heat fluxes, I'm adding words to make it clearer, upward from Venus show several anomalies, the origin of which is still being debated. Taken at face values, the anomalies show that parts of the atmosphere are transmitting about twice the energy upward than is available from solar radiation at the same level. That is, 50% of the heat is now coming from the planet as opposed to 20% at the cloud tops. According to Tomasco, these were the very best readings you would get from the Pioneer Venus probes into the planet. And what was going to be done with them? All the readings were changed. Here's the quote. By adjusting the heat fluxes to reasonable values at low altitudes, they have derived corrected heat fluxes, close quote. What about Venera 9, 10, 11, and 12? Did they at least show that there was thermal balance at the cloud tops? I mean, at the surface. They reached the surface. The 4 Pioneer Venus probes went out of commission at about 7 miles up, or 7 kilometers up. According to Seif, quote, Venera 9, integrated over altitude, showed 45 times the midday solar heat absorbed. This is also true for Venera 10, 11, and 12 data. Integrated over altitude are somewhat less than 40 times the mean midday solar input, close quote. that is, this set of readings showed that Venus was emitting from its surface 40 times as much heat as is coming from the sun. This was averaged. This was an average reading. What were you going to do about these? They said Venera 9 doesn't fit. We found instrument error. These, again, were thrown out. Now, Velikovskians like myself suggest it is completely inappropriate and even irrational to suggest that every single set of thermal imbalance readings which support Velikovsky's prediction regarding Venus's heat should have been thrown out, changed, culled, or ignored to satisfy a predominantly favored runaway greenhouse theory. I say it is sheer hypocrisy to suggest that this evidence does not support Velikovsky completely. I think what I've shown again and again is that the scientific establishment has to invent one ad hoc explanation after another to explain away the evidence fully concordant with Velikovsky's theory, much in the same way as the Aristotelian professors explained away with theories to make the moon be covered by glass or to take on the Tycho Brahe theory, which showed measurements totally discordant with their own view. According to the philosopher of science, Karl Popper, a true science can be devised which creates experiments and makes predictions which would refute the theory. It's a theory of testing. Pseudoscientific theory, he claims, can never be refuted by any experiment, for incompatible results or findings can always be proposed. And this, I suggest, is the nature of the evidence that is being employed by the scientific community to save the concept of a stable solar system. Each of the findings fully are supportive of Velikovsky's theory, have been and are being explained away by one ad hoc hypothesis after another. As for the measured evidence regarding the runaway greenhouse effect, I do not feel it is amiss to say it is dishonest to handle this evidence in the manner it was. To change, correct, or discard measurements again and again that contradict a favored concept is unscientific, unscholarly, unethical, and just plain wrong. I further emphasize that each of the phenomena found on Venus are not only singly congruent with Velikovsky's concept, but each supports the other. They are consistently in accord with his catastrophic explanation, and in this sense create a demonstrable certainty. If Venus is a new planet, it should exhibit an immensely volcanic surface topography, which it does possess. If Venus is a new planet, it should practically have no erosion and no regolith, which it does not possess. If Venus is a new planet, its lava should appear fresh and pristine. Its crater should be undegraded. It should look like a newborn babe, which it does. If Venus is a new planet, its high topography should be extremely young, which everyone has agreed is most probably the case. If Venus is a new planet, all sets of thermal readings should show pronounced thermal imbalance from the cloud tops to the surface, which they undoubtedly show. Each of the phenomena reinforce the other and specifically corroborate Velikovsky's theory. That is why I say Velikovsky's supporters suggest it is the established theories of uniformitarian scientists that fail to pass the test of demonstrable overall unity in their hypothesis, not only for Venus, but I think also for Mars and for the Moon. Each phenomenon must be taken out of context to all or many of the others and receive what I conceive to be a jerry-built ad hoc explanation. Extremely very little pleading is required by the catastrophist theory of Velikovsky. The scientists, I say at this point, who refuse to face the overall thrust and power of this evidence are in an irrational state of denial about what this evidence is clearly showing them about the planet Venus. Thank you.
Do we have questions? All right then. Yes.
Sure. Stay a little louder, please.
How do we tell the difference between a very recently remodeled job on Venus versus brand newness in birth?
I don't think there is too much I can say about that. I'll be quite honest. I don't know if I could explain it. It would seem to me I'm more comfortable with Velikovsky's thesis because of the fact that, to some extent, the newness, the freshness, all of this stuff seems to indicate a strong indication of a new planet. There might not be such a powerful thermal gradient in the atmosphere. I really can't answer your question. I haven't thought about it. It's a good question. Thank you.
All right then. Thank you, Charlie.
You're welcome.